How's it going, everybody? It's been a little while since I've recorded any content for or relating to the security track that I'm currently going down, and that's only because of the fact that I've been busy trying to get other things out of the way and done. So, like I said, it's going to be content will come out on a pretty regular basis once I get into full swing for the security CCIE track, because that's what I'm currently studying for. There's been a lot of requests for CCNA level training and CCNP level training, and they will come. It will just take some time for me to get the content out to you guys, because I'm currently in the process of recording for routing and switching CCIE. So, but one of the first things that I decided to cover was a topic that it's actually the very first bullet item on the secure connectivity for Cisco. So if I was to pull up Cisco's webpage and go to here, if you click on secure connectivity, the first thing you click on here is Cisco Group Encrypted Transport VPN. Now, this was actually a very, at least for me, and because this is a YouTube video, I can be very blunt and very frank. This was actually a really difficult concept for me to get my head wrapped around, because I really wasn't familiar with the concept of group encrypted transport. So it took a little while for me to get the conceptual part down, and that's really the main part of this. Is if you understand the concept of the group aspect of it, it makes it a lot easier to understand the syntax and understand what's going on and how all the components of GET VPN come together. So one of the things that I did, because of the fact that security is such a wide topic area and whatnot, I went ahead and I bought I pay for the subscription to Safari Books Online. So now I have access to almost all the Cisco Press books and whatnot, and even some non-Cisco Press books related to security. So I'm able to dig into non-Cisco specific aspects of the technology, like IKE, IP1, IP2, ISACAMP, the encryption protocols, the hashing protocols, so on and so forth. And so as I was hitting Get VPN up, I was having a hard time with the logic of how it worked. And then after I read up on it, it started to make more sense. And then when I went to do the actual configuration portion of things, I couldn't get it to work. And I was stuck on the mindset of DMVPN, which is the option below here. But unfortunately, DMVPN is a different conceptually than GetVPN is. And even EasyVPN and FlexVPN, which pretty much round out the VPN types. There's some, obviously we have regular IPsec, and then we have things like GRE over IPsec, things like that. But so I decided to dig into it, and normally when I dig into it, I keep going until I get something operationally functioning. So I read through the documentation here, and GetVPN really isn't super complicated to understand. So let's go ahead and click on here. Take a look through the documentation real quick. GetVPN in its basic overview is really a method for you to do this. Let me go ahead and zoom in here just so you guys can see this. So the logic is actually pretty simple. So you have it's actually like 3 steps. So you have the key server, which will act like your DMVPN head end. So you have your DMVPN hub router that all these routers run NHRP, or the Next Hop Resolution Protocol, and your DMVPN spokes will talk back to whatever the Next Hop server or NHS is, and they will form GRE tunnels back to the DMVPN hub. Well, most people get the logic of that, because basically you're taking the point-to-point or site-to-site specific GRE mindset, and then you are basically just making it a VLAN cloud, if you will. Well, GetVPN is a little bit different in the respect that the first thing that you do is the group members are going to register with the key server. Now the key server is where all of your all the core things for GET VPN are actually configured. This is where you configure your crypto. This is where you configure your policies, you know, all that type of stuff. And you basically instruct the group members to call home to the key server. And what ends up happening is everybody's got the same password. Now, I've only tested this with pre-shared keys. I have not gone to the extent of going beyond that. So I don't even know if things like certificate-based authentication or certificate-based encryption, things like that, I don't know if those things are even possible because I haven't gotten that far yet with it. I literally just got this working today, so I figured, okay, well, you know what, I'm going to just, you know, try this out and see if it works. So I did get it working, and I'm going to explain to you guys how what the back end is set up like, and we'll go from there. So the group members are configured to basically call home to the key server. The key server is configured, at least in my case, to accept connections from just about any IP address. Again, this is a lab, so I'm not on production equipment. I'm not trying to, exactly, it's not production. So the group member calls home to the key server. Once it registers with the key server, then the key server is going to push down a policy. This is the Ipsec policy and the Ipsec policy. And what ends up happening is it downloads the information that it needs from the key server, and then it shows up that it was successfully able to connect and all is well. Now once it's gone and it has registered, you have a phase 1 connection to the key server. So you get the phase 1 connection up and running, all is well. And then what ends up happening is, and this is where I made my first mistake, this is going back about a week ago at the time of this recording, that I kept on trying to leverage GET VPN in the same methodology that you would for a regular Ipsec VPN. Now, like I said, I still haven't, I just got this working today, this afternoon, so I haven't really had a chance to really dig into the details yet. I'm definitely not a CCIE in GET VPN. I'm definitely probably CCNA at best. But my first goal was, okay, well, let me set it up to where the transport between, say, this group member here and this key server, the router would have to point to the this is a default route, and as long as the IP address is, as long as I can ping, I should be good. Well, that I could ping, but I still couldn't get the connection up and running, and I was literally just beating my head against the wall. I could not figure out what I was doing wrong. So that's when I dug into a little bit more of the design. Where does it make sense to deploy this? Well, the problem that I run into, at least with most of my customers, is the bulk of them NAT on the internet. So they NAT from some sort of private RFC 1918 address space to some sort of public IP. So GET VPN does not support NAT. So that was one of the first things. Okay, I can't NAT here. And I wasn't NATing to begin with, but it was like, oh, okay. Where this comes into play here is you can still run it over the internet. I am not in my scenario, but you could, as long as NAT is not running on the interfaces that you're trying to peer with. So that was the first thing. So what ended up happening was this cloud that you see here in the middle, I basically turned that into an MPLS cloud, and I turned all these routers basically into customer edge devices. So that was the first thing that I did. It took me about a half an hour to get all the MPLS stuff set up and whatnot, because I'm trying to answer customer emails and stuff like that. Normally MPLS VPN takes me less than 20 minutes end to end, and that's because of the fact that I'm not in what I would refer to as a lab. I'm not ramped up for lab speed, so I'm not labbing 12 hours a day, to try to get myself up. The muscle memory is there. I know what to type in. I'm not like peak performance yet. So I got it up and running, and I was able to ping back and forth and whatnot. Got the connectivity where I needed to be, and then I went ahead and I joined everybody to I got the group members to communicate back with the key servers. I was able to download the appropriate policies. So there's some caveats here, and I'll talk about those here in just a minute. But what ended up happening was I was able to get the group members to peer with the key server, and then the key server pushed down the, which is option 2 here, or the second operation that happens here. The key server pushes down the policy to the group member. And once the group member has that, it says that it registered and it successfully installs the policy as it's supposed to. Okay, so that worked out well. And then what ends up happening, the group members specifically, these are what would be referred to as the customer edge devices. They're able to communicate with one another. The problem I was running into is I was pinging and I couldn't get the ping to work. Well, I had copied and pasted an ACL. So the concept that most people are familiar with when it comes to iOS VPNs for site-to-site, you create a proxy ACL on one router with the source and destination extended ACL. You do the same thing on the remote end, but you flop or you switch the source and destination subnets on the remote end so that there allows bidirectional communication. Well, I had done that, but I had some crazily configured ACLs. So I blew away the ACL and I rebuilt it. But this time the way that the ACLs work in GET VPN is there's going to be some denies and there's going to be some permits. The denies deny that particular traffic from getting encrypted, and the permit allows the traffic to get encrypted. So you still leverage the crypto map at the interface level of the group member. The key server does not participate in cryptography. It doesn't actually forward any traffic. It's just a control plane mechanism, kind of like a BGP route reflector. And then you get your connections to go back and forth, and eventually all works out. So let's go ahead and, is that one all zoomed into? Yes, it is. I want to zoom out a lot because I don't need it quite that big. So what I'm going to do is I'm going to show you a picture here of what I've got going on. And this is a pretty involved topology, but then again, it's just a lab topology. And right now, this topology here is something very simple to work with just to get stuff up and running. And I'm going to go ahead and pull up Secure CRT. So here, this is router 1. Router 1 is up here, and he is a customer edge device. So as you can see, I've had multiple rekeys come across, and all is working out. So what I'm going to do is, in this particular case, router 1, 3, 9, and 11 are your group members. 4, 6, 7, and 8, and 4, 5, 6, 7, and 8 is the MPLS environment. So 4, 6, 7, and 8 are provider edge routers. Router 5 is a provider core. And router 12, in this particular case, is a key server. So that's basically how everything is configured. So I'm going to show you the key server configuration first because it is quite involved. So I'm going to go ahead and bring this guy over here. Now I'm not going to get into all the design components of how GET VPN works right now because there's an entire video series coming here soon. Well, I shouldn't say soon. I'm in the process of I'll be recording a CCIE security course as I go through my preparation, and you'll see how that comes out down the road. So I type in show run section crypto. There's a lot of config, so you can ignore the trust point here. This is also the latest CSR 1000V that has been released. This is 16.6 Everest, I believe. It's the latest CSR release. I mean, it literally just came out like a couple weeks ago. So I'm using that one to do my testing. So obviously phase 1 has to match across all the different routers. So you have to have phase 1 deployed to work. And one of the things that I also had to do is I had to create a public key or an RSA key pair, which is, I don't see that in the running config for whatever. It actually, yeah, I don't see that one in here. It doesn't really make much of a difference at this point. But basically, and that's where this comes into play, is just the rekey for the RSA for the token. But you get your phase 1 here, and then you create your, at least on this is the key server. you create your phase 2 configuration. So you specify the encryption and then the hashing that goes along with that. And then you create a profile just like you would with DMVPN, except for in this particular case you map the transform set to the profile like you would in DMVPN with the profile. But the difference here is you come in here and you specify the group domain of interpretation. This is what gets GET VPNs operational. So you come in and you say crypto group, GDUI group, and then I name my GET VPN. The identity number, basically consider this to be like your bridge domain or your VLAN, or basically what the matching number between all of the endpoints. This is basically what allows the communication to go back and forth between the routers. So you said server local, and then you specify the rekey algorithm is going to be AES 128. The authentication is going to be this RSA key pair. And then we're going to use the transport of an unicast, meaning that the transport you're writing over does not support multicast. Now, if you're in an environment where you have, say, MPLS multicast VPN, or you're on a private layer 2 VPN where it's an any-to-any, like maybe a VPLS or an HPPLS or an PBB EVPN, really doesn't make much of a difference what your transport is under the as long as you have any-to-any communication and that multicast is supported, then you can switch this to multicast if you'd like. I'm choosing unicast because that's what the most common deployments are. And now this is where I specify my IPsec configuration. So I come in here. This would be you're coming into your crypto map and specifying your transform set. You're matching on the proxy ACL, and you're setting your replay counter window. So in this case here, I map profile, which maps to this profile, this IPsec profile, which calls this transform set, which is this transform set. So there's a lot of individual mapping here. So once you've got that in play, this calls back to your profile, and I said match address IPv4 loopback. Well, loopback was the name of the ACL I created. And so all I have to do is, if I want to manipulate this, all I have to do is come in here and modify the loopback ACL, and then do a rekey whenever something happens. And then you specify, in this particular case here, the address is the IP address of the key server that you want your group members to point to. So if I come in here and I do a show IP access list, this access list is kind of involved. Now, mind you, you're not going to get any hits on this ACL. This is just the policy that you're creating for your group members to determine what's encryptable and what's not encryptable. So the very first one you have up here is going to be the GET VPN control plane. So 848 is the port, and then I have this. This is a copy and paste off some blog that I used to help me put it all together. And this is obviously denying these denies. All these denies here mean that this traffic will not be encrypted. So you're denying it from the encryption. So that means SSH, TACAX, BGP, OSPF, EIGRP, NTP, SNMP, syslog, etc. None of those protocols will get encrypted. I do have a permit IP any at the bottom here, which anything that falls outside of this will be encrypted. So that's going to basically what ends up happening. So then once you've got that, then let's go over here to router 1. I'm going to come up here and type in show run section crypto. And then I come in here, you got your RSA key pair, but this is self-signed. This comes by default with the newer versions of CSR because of the fact that it automatically enables SSH out of the gate. So you have your phase 1 policy, and you have your phase 1 information here. So we're saying the pre-shared key is GET VPN pointing back to R12, which means that I have to have reachability to R12. Then you have your GET VPN group. So you have your GDUI group. We need to GET VPN. The identity number is 100. And here all you do is say point back to router 12. And then underneath the crypto map, you grab the group GET VPN, which is specified here. And then this here gets placed underneath the interface towards the provider edge. So I do a show run interface gig 1.14. I have the crypto map GET VPN map applied to this interface. If I come in here to a show crypto ISA, I have an active GDOI configured back towards router 12. Now, if I do a show IPsec SA, you're going to see a lot of stuff sitting in here. So basically, this is really no different than what anybody would normally see for a normal crypto config. Okay, this works. This is how you determine if packets are getting encapsulated or if packets are not getting encrypted and decrypted, things like that. So one of the things that I noticed when I first started doing this is on the ACL side of the router for the key server, is I was denying ICMP, so my pings weren't working, and I was like, well, is this working or not? There's some sneakiness here that I wasn't aware of. So, like for instance, if I come back over here to R1 and I go and I say, well, show IP route, and right now I'm getting a lot of BGP routes. So I'm running BGP between all the provider and customer edge connections, and I'm running EIGRP in the back end here between 1, 2, 3, and 12, just so I can, so router 1 will have reachability back to the key server, and I'm redistributing on router 3, I'm redistributing BGP into EIGRP on 12. So show IP route. So there's some external routes here. So the remote sites. So the connection between 7 and 9, the connection between 8 and 11, and then router 9's remote network are all being learned by 12. And the reason why I did that was because I needed to be able to get the routers, the group members, to be able to reach the key server. So that was really important. So I did that, and then I come in here, and since I have reachability, I can type in show crypto GDOI, and then you can type in IPsec, and you can type in SA. Now what this is doing, this is all of the SAs that are created. Now this is one big SA, right? And the reason why it's one big SA is because of the fact that I've got specific protocols that are allowed to get encrypted, specific things that are not allowed to get encrypted, so on and so forth. This doesn't show you what's actually hitting ACLs. Okay, this is not where you look for that. So as you can see, 848 is being denied. So you have the local identity, you have the remote identity, directionally it's both, so on and so forth. This was throwing me off because I was sitting there looking at it, I'm like, well, what the heck? How come this isn't working? Because I actually thought it was broken. But I was getting a lot of these here, where I was seeing receive rekey, install policy success, installation of registration rekey policies from key server for get VPN and GM identity from VRF default inside VRF default. So I was like, well, everything that I was looking up was saying that I'm registering with the key server correctly. I just couldn't pass traffic. And I'm like, this is where you start to get into the, okay, what am I doing wrong? So that's when you have to start looking deeper into going back to what you understand about cryptography already. So that's when I came to router 12 and I said, well, let me take a look at this ACL. And that's when I noticed that I was denying ICMP any. Now it's up to you what you want to permit, what you want to deny. I chose to allow all the routing protocols because they need to be allowed to talk. So I did that and I said, all right, well, we're in good shape there. So then I went back to R1 and I said, okay, let's go to R9 and let's just see, is everything working the way that I think it is? So I went in here and I ping 10.3.12.12 and I can ping it. If I do a show crypto GDOI IPsec SA, you don't see anything you don't see any information, any numbers incrementing. So it's like, well, is this working? You don't look there. You type in crypto. There's actually two places to look. You can type in show crypto IPsec SA and hit the enter key. Now you're going to have one of these connections back here, and one of these. What ends up happening here is you have your local address. What you're doing, and this is where the group aspect of GET VPN comes into play. All of your group members are sharing one SA. It's not SAs, not an SA from R1 to R3, and then another one from R1 to R11, and then from R1 to R9. It's not three separate SAs. it's one SA. So it's one data plane connection between all the routers. So what ends up happening here is I basically am permitting everything to get encrypted. Now you can be more granular if you want, but this is basically how it's set up. So if I come in here and I do a trace route from 9 to 12, do a trace, and I jump, normally from a connectivity perspective, I would go 9, I'm here on 9, and then I would jump to 7, then I would jump to 5, then I would jump to 6, then I would jump to 3, then I would jump to 12. Right? That would be the trace that I would see. Well, that's not going to happen. And the reason why it's not going to happen is because R1, R3, R9, and R11 are all peered to the same GET VPN cloud. So conceptually, it's similar to the way that DMVPN works, except for DMVPN provides a point to an any-to-any connection over a /24 tunnel, and GET VPN is doing the same thing but encrypting the traffic. So GET VPN is not a routing technique; it's an actual encryption technique, where you could run, in this particular case, I'm running it over MPLS. So if you have an MPLS environment and you want to encrypt it, you don't have to set DMVPN up if you don't want to. So in this case here, it's completely tunnelless. It's only SAs. So I take that into consideration. I hit the up arrow. I show crypto IPsec, and I see 22. So if I hit the up arrow here a couple times and I type in pipe include PKTS, you're going to see data. So if I come in here, now you see that I've got 22 encapsulated, 20 decapsulated. So let me type in repeat 100 times. Okay, so I'll hit the up arrow, and now you're going to see 122 and 120. So we know that it's working. The other one you can take a look at is show crypto GDOI GM data plane, and you type counters. This is where I realized it was actually working, and you'll see that the packet's encrypted, packet's decrypted. So again, if I come in here and I hit the enter key, I got my 100 pings. I go back to this guy, and now I have 222, 220. So it's working. So the GET VPN is operationally functioning and whatnot. It's doing what it's supposed to do. And that was the biggest hurdle for me, was to get this to work, because the last thing I was going to do was move on into another topic without having at least a base functionality of this operating. And that was the big deal, is making sure this worked the way that it was supposed to. So once you have this operational, and let me do a show run pipe and section crypto, the configuration for GET VPN is actually really light on the spokes, or the group members. Now, like I said, I haven't gone into PKI, I haven't done IV2, I haven't done anything fancy other than just get a base functionality working. And one of the things that I'm working on doing currently is I'm working on getting a lot of the theory out of the way first. So I want to get IV1, IV2, AES, all the encryption and hashing algorithms out of the way. And then I plan on coming back. Let me go ahead and minimize this real quick. I plan on coming back to this page. I'm doing GET VPN right now. And I'm going to hit DMVPN, then EasyVPN, then FlexVPN. I'm going to hit them in order as they are here, just so that I know I've completely covered them. And then I'll hit just regular IPsec VPN, GRE over IPsec, so on and so forth. And I'm going to be going through a bunch of different designs. So this is what I'm going to hit first. And then I'm going to do the same thing for the user access, and then what is the other option here? There is go back here once. So you have the secure connectivity, securing user services, and securing the data plane. So secure connectivity is the one I'm doing currently. Then I have securing user services. So I'm actually going to be moving to securing the data plane after that. So I'm going to be doing a deep dive into ACLs, cloud web security, FPM, URPF, and then zone-based firewall. I'm going to be spending quite a bit of time on zone-based firewall. And then I'll jump back here to securing user services and taking a look at all of these, because there's some advanced configuration that comes into play with that. So like you get things like MACsec here. I'm not even sure if MACsec is supported on these routers. interface gig 1.79 and MK. Yeah, I don't think it is, unless I'm interface gig 1 M. Yeah, I don't think it's supported here, but that's basically what it is that I'm working on getting operational and testing out. So like if I wanted to configuring, so I would want, yeah, an MKA. I'm not sure if there's anything that I have to do. Yeah, so I don't think it's supported on the CSRs. So this is how you would set up MACsec, or what they refer to as WANsec here over the WAN. It's MKA. Like I said, I don't think it's supported because I don't see that command available. No big deal if it's not, but that means I'll just have to go get. I'll have to know the configuration in order to test it out. But that's basically how this works. It's more or less knowing what it's doing and how it's working and stuff like that, and go from there. But at the end of the day, it's really no big deal. So I'm just curious to see here if it's. Yeah, I don't think there's any way to, unless it's got to be enabled globally. So keychain 'key' MACsec. Okay, maybe MACsec is supported here, and then key 1 key 01. All right, let's do it that way. I'm just gonna, key string is gonna be, let's just steal this guy right here, just for simplicity's sake. Now you're seeing something that I am just doing off the cuff here. Okay, so we're gonna go back to interface gig 1.79 and then M. So you can create the ACL, but MACsec, I wonder if interface gig 1. Yeah, I don't see the ability to put that on there. Yeah, see, MACsec isn't even supported. I can put MAC address, but not MACsec. So that's one of the things you have to to realize is just because you can do some configuration here doesn't mean that it's going to be supported elsewhere. But again, that's just one of those things that comes along. So I'll be digging more into this stuff as we go along, and I'll be putting out material as we move forward and going from there. There's going to be a lot of content coming out. I'll be hitting, basically I'll just be showing you like the high level stuff on YouTube, and then if you want to see the involved stuff, you'll have to go over to Rikers Island Training and see how it's set up there. Until next time, guys, thank you so much for stopping by, and we'll catch you guys in the next video.